So, welcome to the second class on project time management. Today we are going to see the PERT technique. It's also called MPM in French. The PERT technique is also linked in the US, and because it was developed in the US, to the CPM technique, which is called the critical path method. Okay, but first let's take a look at what PERT does and what it is. Okay. So the program or project evaluation and review technique, it's commonly abbreviated as PERT, is a type of network diagram used in project management. It was first designed by the US Navy in 1957 to analyze and represent the tasks involved in completing the Polaris project. By the way, if you don't know what the Polaris project is, it's a missile. Well, there were lots of them to put together, but the Polaris missile is a missile that was designed for the nuclear submarines of the Navy. And by using PERT, it is estimated that the time they've spent to develop the missiles moved from 7 years to 5 years. So it's a gain of 2 years just because they developed that technique. Okay, so that's a very powerful technique. In a way, it's a complement to the Gantt chart we saw yesterday. It's a way of computing all the values you will need that you may use then on the Gantt chart. It's related to the Gantt chart, and when you use software to do project management, as we saw yesterday, the software will always give you both the Gantt chart and the PERT chart. Okay. Now we're going to see that the PERT is a generic name, but actually other names came to. I mean, the name has survived, but other techniques slightly similar actually became predominant, and the name actually was used for all the techniques after that. So simultaneously, about a year later in France, a French researcher called Bernard Roy put together a method called the MPM, Metra potential method, and that was used to design the French Ocean Line of France, which was one of the biggest in its days, and also the first French nuclear power plant. Okay, and as you can see here, it's on the right screen. So it's very equivalent to the PERT method, but I mention it because it's really the method that has already gained over the last few years. I mean, the last maybe 30 years, and it's also the method used in the CPM method in the US. Okay, but it was first designed in France. All right, so let's take a look at the main difference between what was classically called PERT, and again, PERT has become the generic name for all those techniques, and what was originally the MPM. So let's take a look at the difference between the two ways of representing a network. The first one is called activity on the node, okay? And that's the one you will find on most computer packages and on MPM and CPM. Okay, so the way it works is an activity is represented by a square or a cell, and the relationships are represented by arrows. Okay, they're also called arcs, and the arcs will link the nodes being activities. Whereas in PERT, it's also called activity on the arc. An activity is represented by an arrow. It's a little less intuitive. That's why it's not so much used anymore. And then you put in the cells, you put the beginning of an event. Actually, an event is a beginning of an activity, or the end of an activity. So you can see here that the activity is the arrow. It's called activity 1, 2, and it's between event 1, which is the beginning of the activity, and event 2, which is the end of the activity. And the end of the activity is also the beginning of activity 1. Is also the beginning of the following activity called 2, 3. That's really the name of it. Okay. So that's less intuitive, and we're not going to be seeing this much. We're mostly going to concentrate on these kind of relationships here. And I will use the name PERT to refer to all of them, really. Okay, so as already briefly explained, AON, MPM format, CPM format is a default format in most commercial project management software tools, actually all of them. MS Project, Primavera, ProTrack, whatever, even Project Libre we see today, it's all the same. And why? Because it's easier. Basically, it's more intuitive, and that's why it won over. Okay. So yeah, we call everything PERT, but that's because the name sticked, and we've kept it since then. It was the first technique developed. That's why the name remained. So now let's take a look at a typical project. We're going to take a look at project Omega. And anytime you have to plan a project, it starts always with a project table of activities. Okay. So we saw yesterday something like that. We saw yesterday, I don't know if you remember, we saw the Gantt chart. And if you remember, on the left side, on the vertical axis here, there were tasks. So it's exactly the same as before, except this time the tasks are lettered instead of just putting the names, but we could put the names of the task just as well. Okay, and in front you have the durations. It's like exactly like the Gantt chart. Okay, there is one major difference though in this table here. Is now we mention something called the predecessors. The predecessors are the activities that are before the other activities, the activities that are required before the other activities may start. So here in Project Omega, you can see that there are 3 tasks that will start simultaneously. That's why I put them start, and there are A, B, and C. Okay, and then you have the durations. You have A 6 days, B 4 days, C 10 days. All right. Then after that, if you look at task number D, or name D, you can see that it will last 3 days and that the predecessor is A. Okay, so what does that mean? It means that when you will present it, okay, you will present D after A. Let me go back to this here. Here would be A in activity 1, and activity 2 would be D. Okay, that's how you would represent it. Okay, and we are going to see a network of that right after. E will last 33 days, and the predecessor is also A, like for D. F will last 20 days, 2 predecessors, B and C for F. G, 19 days, 2 predecessors, same as F, B and C. H, 15 days, predecessors D. Again, D comes before H then. I will last 7 days, and the predecessors are E and F. And finally, J will last 21 days, and the predecessor is G. Okay, so how do I put all this into a network, into a representation that makes sense? Well, let's take a look at that on the next slide. All right, before I show you the full network, let me briefly introduce how every task is represented. Okay, every task is represented by a cell or node. You can see this is one of them. Actually, those cells or nodes are squares that are filled up with other squares. So let's see what they mean quite briefly. In the middle of every square, so every node, is the name of the activity. Here I put activity X, okay? And every other little square here will mean something. So of course, I'm going to take you step by step through the meaning of every little square. So the very first thing we mention after the task has been named is the duration of the task, okay? So basically, if I go back here, I will mention the middle of my square A, and on top of my square, middle top, 6. That's what I'm going to be doing, okay? For B, I'm going to present it in a full cell. Middle, I will put name B, and duration 4. So let's see how it works, okay? There we go. This is the network, okay? The network, I can see A here, B and C, they're at the beginning. Why did I put a start here? Well, as you know, we saw that yesterday. This is a milestone. That's a start milestone. Usually we put one when you have several tasks starting simultaneously, okay? To indicate that the start is the one right before A, B, and C. A, B, and C start simultaneously. Also, we found at the end a finish. That's also a milestone, a finish milestone. We saw like they were represented by a rhombus, usually, such milestones on most packages. Here I put a typical cell. Okay. So let's take a look. A, B, and C are the first tasks. A will last 6 days, B 4 days, and C 10 days. Okay. Then, if you remember, it's here. D was after A, and D would lasted 3 days. So we put D right after A. E was also after A, and it will last 33 days. So long duration for it. 33 days is long. B is followed by F and by G. So I put 2 arrows, one linking B to F, one linking B to G. Okay. Remember though that in the table only the predecessors were given. I was only told that G has for predecessor C and B. But when I put together my my network, I start actually with the antecedents. Okay, so that's something you must get used to, but it's pretty fast to get used to it. So I represent every relationship by a square and an arrow. I mean, the relationship is the arrow, and the new task is the cell. So G was following C and B, so it's here. Then H is after D, I is after E and F, and J is after G, and then it's finished. Okay.